In this video, I'm going to talk about the first stars in the history of our universe. Now, we can't look that far back into the history of the cosmos to see these first stars, and when we look around, it doesn't appear like there are any of them left. But while we can't see, we could think. So let's take a look at what's thought about these first stars. From about 100 million years into the universe's history, there is a heightened collapse of dark matter and matter in particularly dense regions in the universe. As the hydrogen and helium gas fell towards the center of these dark matter halos and became more and more dense, it reached a point where these particles started interacting with each other, and when they'd come so close together that their charges would interact with one another, they would release photons. And releasing photons is important because by releasing radiation, you cool the gas cloud. You relieve the amount of pressure and the speed of all of these particles such that these particles can now clump up more easily and become more and more dense. As these hydrogen and helium particles clumped up with more and more density and had the gravitational pressure of a bigger and bigger cloud, the pressure grew and grew, and eventually it reached the point that in the center of that cloud, one proton would be forced to fuse with another, thus bringing about that which differentiates a star from a regular cloud of gas, nuclear fusion. Voila, the first star is born. Now, this started happening like popcorn kernels popping off all across the universe in these particularly dense regions as the first generation of stars were born. Unfortunately, we can't see that far back, but there is hope that the James Webb Space Telescope, which is going to be released in a couple of months on December 18th, will be able to see some of the effects of these first stars, although it's likely that they won't be able to see the first stars directly. Despite the both literal and metaphorical darkness of this period, we can both observe and reason a little about what was going on here. So, first observation. Our main observation is not that we saw the star, but rather that we have not seen the star. Stellar archaeologists, who are the people who do this sort of thing, have looked around the Milky Way extensively and looked at the oldest stars in the Milky Way to try to see whether or not any of these first-generation stars exist. And so far, none. Well, that suggests one of a number of possibilities. Maybe no first-generation stars have lived this long. Maybe we haven't looked enough, and if we look for a while longer, we'll find the first-generation star. Or maybe there are plenty of these stars around, but they've been polluted by inflows of the creation of other stars so that they have heavy element contents that disguise them and make them seem as if they're newer stars than they actually are. And another possibility, and this would probably be the worst for us, is that maybe they're all around and our predictions of the contents of the early universe, and therefore what we look at to try to find the star made up of those components, namely hydrogen and helium, maybe we're wrong about the distribution of the elements at this time period, in which case we wouldn't actually know what we're seeing when we saw one of these original stars. Stellar archaeologists, for what it's worth, are convinced that no, we've looked enough and none of these stars actually exist. And there's a good reason to think that, and here's why. The first stars were made almost solely of hydrogen and helium, with trace amounts of lithium. That has implications for how such a star would form. As we saw, in order for a star to get fusion going, it needs to cool in its center to be able to clump up sufficiently to get the gravitational energy at a strength to bring about fusion. But certain particles are better at cooling than others, namely heavier particles. Because of all the different electrons and all the possible orbitals for those to jump down, it's much easier for a heavier element to release energy, and therefore cool. And that means that when you're looking at cloud forming of hydrogen and helium, it's much harder for it to release energy, and it takes much more time for that cooling to happen and much more hydrogen and helium to build up that gravitational pressure, and therefore these initial stars would be humongous, and humongous stars live fast and furious lives, and they'd all be way dead by now. So that's our vision of the first stars. If you found that valuable, like the video. If you're into big history, definitely subscribe. Until next time.